Previously, we were looking at the various uses of determinants in which we saw how to utilize the concepts of determinants to identify uh, whether three points are collinear or not, or whether they form a triangle, and if yes, what is the area of the triangle. Okay, moving further, this is the next application or use of determinant. Okay, if a1x plus b1y plus c1 equal to 0, comma, a2x plus yeah, a2x plus b2y plus c2 equal to 0, and a3x plus b3y plus c3 equal to 0 are the sides of a triangle, then the area is equal to, then to calculate area we use this formula. A is equal to, this is capital A, 1 divided by magnitude of 2 times C1, C2, C3. Okay, there's difference. So what C I wrote earlier are small letter C's. Okay, so let me try to differentiate. So these are my small letter C's. Okay, these is small a1, b1, c1, a2, b2, c2, a3, b3, c3, all are small letters. But the C which I'm writing now in this equation are capital. All right. See, 2 times capital C1, capital C2, capital C3, magnitude, you neglect the sign, into the determinant of determinant of A1, B1, C1, A2, B2, C2, A3, B3, C3, the determinant whole square is the answer, where the C1, comma capital C2, comma capital C3 are the cofactors of the elements small c1, comma small c2. So this is the small letter small c2 and the small letter c3 respectively. Okay, we'll solve problems to understand this. Okay, so the equations are like this: minus 4x1 plus 5, 4 times x minus 4 into x. Okay, minus 4x plus 5y minus 7 equal to 0. This is the equation, first equation. Okay, then this is 2x minus 3y plus 3 equal to 0. Then minus x minus y plus 17 equals to 0. Okay, so these are the three equations given. Now, I first have to find out I need a determinant for sure, right? So determinant of A1, B1, C1, A2, B2, C2, that's what is needed for by default. So let us try to calculate the determinant first. So I want the determinant minus 4, 5, minus 7, 2, minus 3, 3, and minus 1, plus 70. So the determinant comes to be minus 102. All right, we got this. Now we need the cofactors, specifically C1, C2, and C3, right? So let's write from this determinant itself, we can write the cofactors. So cofactor cofactor of -7. How do you find out this? I know that I calculate the cofactor as -1 to the power I plus j, right? I have to multiply that with this concept, minor of a, okay, minor of that particular point, right? So how do I calculate the minor? So this is actually 1 comma 3. So -7 is at the position 1 comma 3. So this is -1 to the power 1 plus 3 into the determinant of 2 minus 3 minus 1 minus 1. So you calculate. Similarly, we'll calculate. This is going to be whatever we write. This is the C1, capital C1. So C2 can be calculated in the same way. That is for 3, right? So this 3 is located at position 2 comma 3. So second row, third column. So this is -1 to the power 2 plus 3 into, right? I remove that column and that row from the matrix. Remaining, I have -4, 5, -1, and 1. So that will be the cofactor C2, and I need C3 as well. C3 is the cofactor of a matrix for cofactor of 17. So that is 3 comma 3. So this is -1 to the power 3 plus 3 to the determinant of -4, 5, 2, and -3. Okay, this is -5, -9, 2. So all right, let's move further. Now we need to calculate the area by using the equation. The equation, according to the equation, simply substitute area is equal to 1 divided by the magnitude of 2 times -5 into -9 into +2. Anyway, even if you don't write the magnitude, this is positive because two negative quantities, okay, into the determinant square, right? Already we have solved the determinant, and determinant is 42. Okay, so we'll put it over here. So into 42 square. So the answer comes to be 9.8. All right. One more question of the same time. The equations of the three lines are x plus 2y plus 3 equals to 0, minus 4x plus 3y plus 6 equal to 0, 2x minus 7y plus 9 equal to 0. Calculate the area of the triangle. Right? So the area comes to be 10.02. Okay, the next usage of the determinant, the equation of a straight line passing through x1, y1, x2, y2 is determinant x, y, 1, x1, y1, 1, x2, y2, 1 equal to 0. Right? It's very simple. Anyway, we know that we can find it using even the other method. of analytical geometry. But the use of determinants can also be applied here. Okay, so the question is to find the equation of the straight line which passes through 1 comma 1 and minus 4 comma, this is 4, minus 4 comma 7. So you have to solve x, y, 1, 1, 1, 1, minus 4, 7, 1, and equate this to 0. So the answer is minus 6x minus 5 minus 11. So negative, all the terms are negative. You can cancel to write 6x plus 5y equal to 11. Right? Okay. That's how we can solve. Moving ahead. The three lines a1x plus b1y plus c1 equal to 0, comma, a2x, b2y, c2 equal to 0, and a3x plus b3y plus c3 equal to 0 are concurrent if the following condition is satisfied. That is a determinant a1, b1, c1, a2, b2, c2, a3, b3, c3 becomes equal to 0. Okay, so if this condition is satisfied, only then we have the three lines are passing through a common point. So what is a concurrency? So we say that three lines are concurrent only under this condition. Line number 1, line number 2, and the line number 3 will pass through a common point. Okay, if this condition is satisfied, then you say they are concurrent. Okay, right? So first question. Okay, check for the concurrency. In the sense, check whether they are concurrent or not. All right, so this is 4x minus 7y plus 13 equal to 0, minus 8x plus 15y minus 17 equal to 0, 3x plus 4y plus 81 equal to 0. So I just have to check, I have to find the determinant, and I need to check that whether it is 0 or not. If it is 0, the answer is yes, otherwise it is no. So 4 minus 7, 13, minus 8, 15, minus 17, 3, 4, 81. Find this determinant. This determinant is equal to minus 48, not equal to 0. So you can give a statement that the three lines are non-concurrent. Okay, let's go for another question of slightly different type. So if x plus 2y plus 7 equal to 0, minus 4x minus 7y plus 21 equal to 0, and minus 2x plus y plus constant k equal to 0 are concurrent, then find k. Right? In this case, I have to equate them the determinant to be 0 with the k in place. So that is 1, 2, 7, minus 4, minus 7, 21, minus 2, 1, and k. Keep k as it is and equate this to 0. So left hand side you solve, right hand side will be 0 always. There is a k remaining in my equation. Solve for k. So after solving this equation, we get the value of k is equal to 231. If k is 231, then the three lines will meet at a common point. They become concurrent. Okay, moving ahead. So if ax square plus 2 times h into xy plus b times y squared 2g into x plus 2f into y plus c equals to 0. If this whole equation represents a pair of straight lines, right? If this kind of equation we write represents actually two straight lines, then there is a condition that we can write in terms of the determinant a h g h b f g f c. This determinant should be equal to 0. Only when this condition is satisfied, we can say that yes, the given equation contains two straight lines. Okay, let's just check with a problem, right? This is to check if 4x squared plus 16xy plus 2y squared plus 18x plus 22y plus 11 equal to 0 contains two straight lines. So I just have to compare it with the given, I have to compare the given equation with this. So this is, I can find that a is equal to 4. So 2 into h is equal to 16. So h is equal to 8, right? So b is equal to 2. Then 2g is 18. So g is equal to 9. 2f is equal to 22, right? F equal to 11 and c is equal to 11. So I have to find whether the following determinant gives you a 0, right? So a, that is 4, h, that is 8, then g, which is 9, then h, which is 8, b, which is 2, then f, 11, then g, 9, f, which is 11, and c, that is also 11, right? Check that whether what is the value of this determinant. So this is equal to 322, not equal to 0. So the answer says that this is not, this particular equation does not contain a pair of straight lines. All right, okay. Next one. If 2x squared plus, yeah, this is 10xy plus constant into y squared plus 25x plus 44y minus 15 equal to 0 represents a pair of straight lines. Calculate the value of k. Okay, so now what we have to do, right? We have to write a very similar determinant with the k in place and solve for k. So when we solve for k, we get k is equal to minus 30.46 as the value of k, such that this equation contains two or a pair of straight lines.